guys, I'm Jan. So I've been doing Windy City Rails for a long time, so I just want to give a shout out to the people organizing this conference. My first talk was, I think the first Windy City Rails was in 2008, and at that time I talked about virtualization, which was like a brand new topic in 2008. So today I'm going to be talking about containers, which is like the next generation of virtualization, right? So kind of a nice closing of the loop. So I titled this talk DevOps Sauce for Your Rails Pizza because I had no idea what I was going to talk about when Ray asked me to speak, but I knew it was going to be infrastructure related. And I also want to use the word DevOps because I think it's a terrible word that gets thrown around all the time, so I used it kind of ironically. DevOps is not about tooling. DevOps is a thing that you do in your organization to make sure that your developers and your operational people are one team. They're working together. It means your operational people, your infrastructure people are writing code. It means your developers are owning their own services. And we're going to talk about how we got there at Reverb. A little bit about Reverb itself. So we are about a 5-year-old company. We are Chicago native. We are now the top destination for musicians in the world. We are a top 500 Alexa site in the US for buying and selling gear, learning about your favorite instruments, artist interviews. We do it all, content, sales. And it's been an interesting growth trajectory. I was here in 2014. Was anybody here for my talk in 2014 about monoliths? No, not a lot of people. So in 2014, I was talking about how Reverb was a monolithic application. We started out with a Rails monolith, like I think everybody should, because it's absolutely the best way to get something off the ground. You start an app, you start to iterate on it. When you have a small team, like in 2014, we had probably 5 developers. It's absolutely the thing to do. And we started to develop a few services because the surface area of our monolith was growing at that time. But we were still primarily monolithic. And at that time, this is my quote, this is what I said, this is from my slide, maintainable monoliths can be achieved. And since I'm standing here again 3 years later, I wanted to grade myself. This was us in 2014, our code climate GPA, which is basically a score of complexity, 3.5, it's like a B+, maybe a little over. We had 126 models, 164 controllers, 622 domain classes. And that's kind of, if you guys haven't seen this talk, I really encourage you, of course, to watch my talk from 2014, where we talked about what domain layers are and why you should build one. Today, we have twice as many models and controllers and 3 times as many domain classes, but our GPA is actually higher. So I want to like take a bow. I've actually achieved a maintainable monolith. So I actually absolutely think everybody should be doing this. So don't take my talk today, which is going to be very service-oriented, to mean that I don't think that you should be building a Rails monolith. Please, go ahead and keep doing it. DHH is still the man. But this is what our universe looks like today. So we have our Rails monolith, which takes all the traffic, go to reverb.com, buying and selling gear, reading articles, whatever, all that traffic's going through this monolith. Now that monolith will then also invoke a few other services. Some of them, the ones that we had already built in 2014, things like auction management, a service that manages our advertising component, which tracks bids and impressions, things like that. Those are still involved in serving the request. And then there's now an ecosystem of services that sprouted around that are kind of like background processes, things that shuttle data from one data store to another, things that crunch personalization numbers to try to figure out, what kind of shopper are you. All this kind of background stuff going on, right? So we developed quite a rich ecosystem of services, and I'm going to talk about why we went that route and how you might get there. So we love services, right? Every conference you go to nowadays, everybody's talking about services. I mean, it's been the case for the last 10 years. I think that there's nothing really new to talk about here, except for there's probably a million different ways to get to a place where you are in a service-oriented architecture. So I want to talk in a more opinionated fashion about what I think is one of the ways to get there that worked for us. So, but first, like, why do we even want to do services, right? I mean, aren't monoliths awesome? Yes, they're great. But when you get to 5, 10, 15, 20 developers, 30 developers, you start to feel some pain. Some of that pain includes dev onboarding. You hire a junior developer. Now you have to explain to them this entire code base, which now has, like I said, 3,000 different classes in it. Good luck, right? They can't be productive in that code base. They can't be productive quickly, at least. The other problem is estimation becomes very hard. You have no idea how long something's going to take because you start to work on a feature here, it affects something else over here, you end up having to talk to this other team that worked on it 3 years ago. You just have no idea what's going on anymore, and it makes things really, really hard. Now, we have not stopped maintaining and developing on our monolith. We still believe that the monolith can end up being sort of the center of our universe in terms of the most core functions of our site. Order, tracking, making sure that that whole inventory tracking and order system is solid is kind of the basis of it. But there's all these peripheral things that need to happen that don't need to be on that core code base. So we can actually increase the speed of onboarding and the speed of development by having separate code bases that are smaller. The other thing that services really encourage is ownership. In a monolithic environment, again, 30 developers, a code base with 1,500 classes or whatever you have, impossible to define ownership. Now we've tried a bunch of clever tricks. We've tried to label controllers with what team owns them and things like that, but it's really, really hard. All the tooling around these things like PagerDuty, if you want to alert somebody that something's on fire, good luck trying to figure out in a Rails code base who should be alerted, right? There's so many people that have touched this thing. So with services, what we start to do is create separate code bases and we say, hey, this team, 2, 3, 4, 5 people, they own this service. If the service goes down, they're responsible for it. And they feel ownership. It's not like we're pushing this onto them. They feel pride in their code base, right? They want to make sure the code there is good. If you have a Rails monolith with 3 or 4 years of legacy code in there, no matter how well you try to set it up in the first place, people are going to be a little bit like, hey, maybe that's not my problem. Like I found a hairy piece of code, maybe I'll just not touch it now because like I'm trying to get my feature done, right? Whereas in a service-oriented environment, people tend to really care about their services and they care that they're running and they care that the code is good and they can onboard people quicker. Finally, with smaller code bases, we're really trying to reduce the complexity and error, surface area for errors, right? In my Rails monolith, I can make a mistake over here, it will affect the entire site. First of all, because the deployment's monolithic, meaning like I'm serving this entire site for one big Rails app. And if I make an error in some, filter in some controller, I will blow up the whole site. Or I'll make an action that's too slow and it will starve my unicorns and my site will go down. Like I don't want that stuff, right? I want to isolate errors to smaller surface areas where if it's in a code base that I can understand and reason about and put in my head, I'm less likely to make an error in the first place. And in the worst case scenario, if I make a bug in my service, well then the service is down. It's not that like the whole site is down, right? So this is really good for our customers. But this doesn't come for free, right? You can't just say, okay, yeah, let's service orient all the things. There are many, many complexities that come with moving to an environment with services. So we have to make good trade-offs. When we think about moving our, abandoning our monolith or starting to add to our monolith with a service-oriented ecosystem, how do we reduce the complexity? And what kind of complexities do arise? Well, one of the problems you start to see is polyglot environments. Polyglot just means many languages, right? When we started out, it was Rails. Everybody knows Rails. Everybody in this room knows Rails. We love it. We know how to deploy Rails. We know Capistrano. We love it. We hate it. I don't know, but it works. SSHs to a bunch of servers and it uploads code and, that's cool. And it's fine when you have 5 servers and 10 servers. Now you have 15 and 20, 30. You start to worry about what happens when your SSH connections break. What happens if my deployment didn't quite make it halfway? How do I roll back? I've got people deploying on top of each other. Okay, that's complexity. But that's complexity just in Rails. Now we want our teams to use Python because we have a data science team. And they came on board and they said, okay, we want to build stuff. We want to analyze data, but Ruby tools around data analysis aren't great. The ecosystem is really Python oriented. Why can't we write services in Python? Great, write your services in Python. But what does that mean for our operational complexity? That means we now have to understand how to deploy Rails, how to deploy Python. Now we have Golang because we need to have high performance services. So now we need to know how to deploy that. We need to know how to deploy Node and JavaScript. You just create all this complexity in deployment, understanding scenarios where these things can fail, how to manage them, all of that stuff. It becomes really complicated. We also need to solve the problem of monitoring and logging. When we had one app, it was pretty easy. We had one app, one server, we could SSH in, we could tail the log, fantastic. And we had 10 servers, okay, so we built some log aggregation, funnel all those logs into one place, cool. But now I have a service sprouting every month. I have a new service every month and okay, what are they going to do with their logs? How are we going to monitor their service? How are we going to do this? We don't want to have to reinvent that wheel every time. That's complexity we don't need. And how do we make HA and scaling, HA meaning high availability, how do we make that easy for our developers? When they stand up a service, I want to make sure, hey, if that service goes down, another one will come and take its place. I want to make sure that if the service is under load, I can click a button and get more of them. I don't want to have to reinvent that wheel every single time we launch a service. That's very complicated and very costly. And remember, our whole objective with services is to make things faster, simpler. We want to develop faster. We want to have less errors. So all these complexities are going to start to creep in. We're moving from complexity in the code base to complexity between the services, right? And then finally, we need to figure out how they're going to talk to each other. When you have Rails, you start with a messaging pattern that's already built in, active job or sidekick, rescue, any of that stuff, right? It's really good because when you start out with a Rails app, like they give you a for free, super simple to use mechanism for having background jobs. You call delay on a method and like magically things happen. You don't even have to understand what's going on, right? But what that encourages is for you to centralize all of your background jobs and all of the peripheral things that make your site work into that same code base. So we have our Rails code base that's also serving the emails, it's also doing data crunching that's totally unrelated to Rails just because we have that one code base and we already have a built-in messaging system with Sidekick and Redis, and more or less people understand that stuff. It's very easy and like the code is simple. So it's great when you get started. It's a problem when you start to get into Polyglot environments and I want to actually send messages from Rails to a Python app or I want to broadcast a message and have other services react to it. So we're going to think about how to solve these problems. We're going to apply our Reverb philosophy, which is most importantly, KISS, keep it simple, stupid, or keep it stupid, simple, however you like to think about that. We want to choose the simplest possible tools for the job, right? Like, we don't want to pick tools we don't understand. And a lot of times that means using what's in front of us. I see people starting a project and saying like, hey, I've never done Mongo before. That seems like a cool idea. Let's do that, and like, let's take that to production. And it's not a good idea, right? Nobody understands that stuff. So when you choose technologies, choose something that people understand and have familiarity with. And only deviate from that when that choice is going to radically simplify your life, right? If you're going to introduce simplicity by taking a new tool that maybe people don't understand, that might be a good trade-off, but it's a very, very careful trade-off you have to make. So the first thing we did was Dockerize everything. How many people here are running Docker in development? Okay, a couple hands. We're good? So why do we want to Dockerize? What is Docker? Docker can be a daunting thing when you just approach it because the ecosystem is so vast and so rapidly changing. So I'm going to give you like a really lightning tour of what Docker is in a most non-scary way possible, which is to show you code. This is a Dockerfile, okay? This is an actual Dockerfile from one of our Ruby services, and it is all of 23 lines of code. So it's not scary, I promise you. Let's just go through it really quick. What a Dockerfile is it's a recipe for running your application in a Linux environment. That's all it is. That's the way you can think of it as. It's basically like a virtual machine, but it boots instantly. You don't have to think about how the technology works. Let's just talk about how to make one. So here's our Ruby service. At the very top, we say from Ruby 2.3.1. What we're saying there is that we're going to go to the community Docker image repository, which is called Docker Hub. And we're going to pull something that somebody's already figured out how to do. They already know how to make Ruby environments. We're just going to grab that and we're going to use it because we're cool with whatever they did. On top of that, we're going to install a bunch of Linux packages that we need for our particular application. Now, we use a Postgres app. It has the Postgres gem. It has no-code-giri. Everybody loves those gems because they need C bindings to compile. So we need to install a bunch of junk for that to happen. Fine. So we do that. We Google how to do that. We put that piece in there. And at the very end, we say add our gem file, run our bundle install, and add the source code of our application to the Dockerfile. This is the entirety of the thing. You can literally go and copy this into your Ruby application and it will just work. Okay, 23 lines of code. Could be simpler. Then, once we have this recipe, now this recipe again is describing what it takes on an operating system level to run our application. We're going to run Docker build. And you don't have to understand all of the output here, but basically what it's doing is it's going in and executing each one of those lines in the Dockerfile, but it's doing it in a smart way, in a way that is cached. So if we only change the source code of our application, the entire container doesn't need to be rebuilt. This takes a few seconds, usually. Now that we have our Docker container, this is basically an image now that contains not just our application, but also the operating system required to run it. In this case, it's Ubuntu or something like that, or some flavor of Debian. We're going to push this image to a repository where we can share it with other people. And in our case, we use Amazon. So we're going to create a repository that is one line of code, AWS ECR create repository. It makes us a repository, it gives us a URL. Then we're going to tag our image to go to that URL. So what we're saying there is tag the image we had just built with this URL and push it. And now Docker will upload this image to the repository for us. Again, because it's cached and smart, it will only do the changes and it will be fast. And now we have our image in a repository for other people to use. Cool. So quick recap, because that was lightning fast. We wrote a Docker file which describes what our app does, what it needs to run. we created a build which made an image, and we uploaded that image to a repository. How do we use this in real life? Well, every service that gets built does this, right? Every Ruby service that has a Dockerfile, every Python service has a Dockerfile. What this means is that your developers, being the people who know how to set up those environments, are the ones writing these Docker files. The Ruby people know how to write Ruby Docker files. The Python people know how to write Python Docker files. And if they don't, they go to a project that already has done it, and they copy and paste. It's very simple, and usually these things are 20 or 30 lines of code. So that allows you to have an ecosystem where all of the developers are responsible for just making sure that their service can actually run by executing Docker build, and they can start that service on their laptop. So the other piece of this is called Docker Compose. This you can think of as almost like the foreman of the Docker world. It's a thing that tells you what services you need to start up. So this is an example, again, almost verbatim. I did strip a couple lines from here, but it's more or less 10 lines of code. And it describes one of our services, in this case, a service called Search Indexer. Now this happens to be a Golang app, but we don't have any idea about that because the Docker file has already been built, and the image has been built, and we don't know what's inside of it. All we know is like it runs, right? So the Docker Compose says, grab this image from this repository, inject it with these environment variables, which we can specify at runtime, and run this command, which in this case is Search Indexer, which is basically just like what will you do when you get into the container and run, what binary do you need to execute. And then you specify ports, like what port do I need to expose on my machine when this runs. So when I type Docker Compose up, that service will start up, and I can go to localhost, port 8080, and that service will be running. Very, very powerful. So every one of our repositories in GitHub has a Docker file that describes how to run it. It has a Docker Compose file that describes how to start that service with all the parameters it needs. Now let's take it back to the most complicated example possible, which is our Rails monolith. So our Rails monolith is not yet Dockerized. We're working on it, but it is a lot of work. It's not a lot of work to do for smaller, newer services because you're starting from scratch. But for Rails, and with all the dependencies we have there, it's more complicated. So we're working on that. But what we are doing is we're solving our development story with our Rails monolith. So as I mentioned, already in 2014, we had 3 services. We had our Rails core, what we call Reverb core, and then we had Auctioneer and Bump, our auctions and advertising services. Now, because they were all Ruby services and they were all deployed with Capistrano and all that kind of stuff, everybody kind of knew how they worked. And in development, we would tell people, hey, you're a new developer at Reverb. Okay, go here, run this script. It will set up this one service, run this other script. It will set up this other service. Go to your Reverb project, run this other script, and it will set all the things up. And over time, we got better at that. We wrote scripts that started up Vagrant VMs and ran all that stuff inside of there. And it just, it worked, right? But it was complicated. Docker Compose completely wiped all the complexity away. Because not only did we need all those services, we also needed certain typical databases, Postgres, Elasticsearch, things like that. So we wrote it all into one Docker Compose file. This is the file in our Rails app, in our Rails monolith, that tells us everything that it needs to run. So at the top there, you can see we have a service called DB, the database. And we're going to pull it from Docker Hub, again, that open source repository of things that the community has built. We're just going to take an off-the-shelf Postgres image. We're going to tell it to run on a certain port. That volumes directive basically says save the data, so in case my Docker dies and restarts, it'll still be there. We're going to run on off-the-shelf Elasticsearch. We also do the same thing for Redis, for Memcache, for you name it. There's probably 10 or 15 things we need for this thing to work. So we just write these things in a file. But we also reference the services that we have built ourselves. An example here is Bump. So 3 lines down, you have the Bump container, and it says pull from that Elastic Container repository that we had just pushed to. And so when any developer at Reverb now starts, they type one command, Docker Compose up. It will fetch all of the images, community images, images that we built. It will start them all up with the correct environment variables on the correct ports, and everything will just work. So we've solved our development story. And it's beautiful. And for the most part, Docker has its rough edges, but it really works really well. And it's definitely better than writing custom scripts for this stuff. But now let's talk about production. So can I see a show of hands again for who's using Docker in development? Cool. And keep them up if you're also using it in production. Okay, so like a bunch of hands just went down. Docker in production can also be a daunting thing because of, again, the newness and the largeness of the ecosystem. So first of all, let's just talk about what it means to do Docker in production. Why do we want that? Well, this is our old school development story, right? A deployment story. We have our Rails app, and we have a bunch of Amazon EC2 instances. For all practical purposes, we can think of them as hardware. We have a bunch of hardware running out there, and we're going to push this app into these EC2 instances. So we're going to start by doing a Capistrano deploy. It's going to SSH in. It's going to upload the code or download from GitHub or what have you. We start containers, or sorry, not containers. We start unicorns or whatever is running your Rails. And you've got your load balancer, directing traffic to them. This is great, wonderful. Works when you have one app, fantastic. Now you start to get into this environment, right? Like I said, we have a data science team that uses Python. We've got some services that need Golang. Now our world is a little bit more complicated. We need to deploy to lots of servers. Some of them need multiple copies of a thing running. It becomes very hairy. So here's how Docker solves this. This is what Docker lets you do. Docker lets you stop caring about what is inside of those containers. As long as I know that my developers have built a Ruby image that works, I don't care that it's even Ruby. I don't care if it's Python. I don't care if it's Elixir or some cool new thing, right? They can stuff that into a container, and as long as I can write Docker Compose up and make it run on my laptop, I know that I can do the same thing in production. So this is my goal. My goal is to be able to say, hey, cluster scheduler, here is a Docker image. I want this much memory, I want this much CPU, I want it to open up this port. Go, figure it out. I don't want to have to do this myself, right? I don't want to have to go sit there and figure out which instances are going to run which containers. And that's what container schedulers are all about. And again, it can be extremely daunting because you get into Kubernetes and Mesos and all these fancy words, and like your eyes start to glaze over as soon as you start to read about them because they're all really, really complicated. So these things are what they are cluster schedulers, right? They basically take your Docker containers and allow you to describe what you want to happen in terms of memory, CPU, and number of instances and ports, and they like figure all that out for you. But each one comes with its own complexities. Kubernetes is actually probably one of the most popular ones, and Amazon even signed up to kind of be on board that effort. So I'm really excited for Kubernetes to come to Amazon. Right now, Kubernetes is available on Google Cloud as a hosted product, and if you're on Google Cloud, 100% try it out. If you're on Amazon, running Kubernetes means running a bunch of extra stuff that you have to maintain and understand, and that's a problem. You also have Mesos, which is kind of like an Apache project, which has a really big ecosystem, and it's more of a roll your own. Like you have to figure out which of these plugins work with which of those plugins, and again, it gets really, really hairy. And our philosophy, again, is keep it simple, right? We want to keep it extremely simple. What can we do to keep it simple? What can we do to use the tools that are in front of us? Well, it's Amazon ECS. Amazon is our platform where we run all of our cloud stuff, and it's 100% awesome because they keep delivering new projects for us to try, and that's great. ECS is their container service, and it's kind of like a baby version of Kubernetes or Mesos or one of those things. It does some of the same stuff. It's not as flexible. It's not as fast. It has rough edges. It's not friendly for developers, but it works, and it's in front of us, and we don't have to run this infrastructure because this is Amazon's infrastructure. And that's huge. That's huge when our business is being a marketplace. We are about selling gear to people, right? We're about educating people on like what the coolest new stuff is and reading artist interviews and all that. We're not about creating complexity for complexity's sake. And at the time we made this choice, our infrastructure team was a team of one. I was the CTO at the time, and I was managing this one person, and like I was doing a bunch of other things, and I just didn't feel like Kubernetes was going to be a wise choice when we had one guy who's going to be trained on it. That was a real problem. So making the simple choice, we decided to go with Amazon ECS, and the first thing we did was try to understand like what will it take to deploy an application on ECS. Well, it turns out you have to write some JSON to describe what you need to do, and like you tell it about the JSON, it deploys your containers, it more or less does the right thing. But when you need to make a new deployment, you need to version this JSON, you need to write more JSON, and then like there's not really a good solution for logging, and there's not really a great solution for how to store your secrets. You start to see all these like rough edges that all these fancier systems like Kubernetes and Mesos have already solved, but ECS is more of a do-it-yourself system. So it became obvious to us that this was not something we wanted to teach our developers. We didn't want to have people understanding how ECS worked just to deploy their app. That's not going to scale. Again, the whole premise of going to a containerized world is that it's easy for developers and easy for infrastructure people. And this didn't seem like it. So we started looking at GitHub in terms of like what had people done on top of ECS. And we found like a whole bunch of projects. People had written deploy scripts. Each one of them was slightly not quite what we wanted. Each one of them was slightly not quite where, solving all these different problems. Then we came across Khanbox, which was really cool. Khanbox is a system that was built by ex-Heroku people. In fact, David Dollar, who is the author of Foreman, if you guys use that for your Rails startup stuff, he is the CEO of Khanbox. Khanbox is an open source project, so I'm not like shilling a company here, but, but they do have like paid support plans and everything. But basically what they do is they create all this infrastructure for you. Starting from the networking layer, they build a Amazon VPC, which is in and of itself a huge pain. To understand all the networking, like you will study a level of networking that you never wanted to know if you ever want to try to build one of these things yourself. It builds that for you. It creates a set of instances in an ECS cluster for you. You just tell it how many and what size. And then it manages all your deploys. Now I'm going to throw out a lot of terms in this explanation, but it's just to kind of give you an illustration of the complexity that they manage for you. So when you do an Amazon or a Khanbox deploy, what you're really saying is they give you a Heroku-like command line. You just say Khanbox deploy. They take your Docker Compose file, which we've just written, right, in development that we know already works on our laptops, and they translate it to Amazon speak. They will create container definition files for you. They will create a recipe called CloudFormation that Amazon knows how to process to do all these things. They will deploy your containers. They will store you know, a record of your deployment in DynamoDB, which is Amazon's kind of NoSQL database. They will store your secrets in S3 buckets. They will encrypt them with KMS, which is Amazon's key management service. They will manage SSL certs for you using Amazon's cert service. So the cool thing about Khanbox is they're not introducing new infrastructure. They're just introducing sugar on top of what Amazon already does. Most of all, they're just creating API calls for you. That's all there is to it. So we felt really good about the system, even though it was super alpha and it had bugs. So it was a choice between taking an alpha system that we knew was going to have issues, or it was a choice of taking Kubernetes, which also wasn't quite 100% production ready, I would say at the time, or Mesos. All of these things, like some people running it at some of the time, people were, you know, frustrated on forums. It was just a nightmare. So we looked at the system. We said, this is so philosophically aligned with what we believe in. We really believe in using the tools that we already know. We don't want to have to run an extra infrastructure. So we're going to bite the bullet. And we did. And we adopted Khanbox. And the best thing about it was we didn't have vendor lock-in because it's just a Docker Compose file. So we knew that we could eventually translate it to something else if it didn't work out. And this is basically an output of just running Khanbox PS. This is essentially showing us the container list from one of the apps that we run. And this is our most complicated app. It's our most microservice type app. You know, I'm not a microservice evangelist necessarily, but sometimes it makes sense. So in this case, we have 7 different containers that need to be running for this app, or maybe even more. What they are is basically in the Docker Compose file in this project, they describe all the different containers and all the GitHub repos they need, and it runs. So Khanbox has solved a lot of problems for us. Logging, it solves that. It takes containers and aggregates them into CloudWatch groups, which are Amazon's centralized logging. We can then pipe those into our own centralized logging system with one command. Fantastic. We can scale with Khanbox scale, just like Heroku. They even have a scheduler, so if you want to run something on a cron, you write a one-liner in your Docker Compose. They translate that to Amazon Lambda functions and scheduled Lambdas and all this. You don't have to worry about any of that because it just works. But best of all, it gives us dev prod parity, right? Docker Compose here, Docker Compose there. Finally, really quick, because I know we're probably running out of time here, because I got that light flashing. Messaging. We looked at a bunch of messaging systems. A lot of people like Rabbit. Rabbit's super complicated. If you start reading about its clustering mechanisms, your eyes will glaze over for sure. It's not friendly for operations. So we found an SQD. I'm not going to go into the details of this, but if you guys are really interested in messaging and how to go to scale your system from one Rails app to many, I really recommend looking at NSQ because it's basically an agent you run on a box and it just works. There's no centralized piece to it and it's very easy to maintain. And this is the code. You know, I always go back to that old DHH adage of, is the code better? This is the code to publish and consume messages in NSQ. The publisher is one line, the consumer is a couple lines, and the consumer can be written in any language. They have libraries for Python, Ruby, Golang, you name it, they've got it. So if you're looking at messaging systems, highly recommend checking out NSQ. Again, we adopted it pretty early, but it was so simple that it seemed like it was an easy choice and we could always throw it away. So that's it. Thanks for listening. I'm not going to get into this. This is basically how we do everything else. We are hiring, jobs.reverb.com. If you are interested in any of the things that I talked about, we develop in Ruby, we develop in React, and that is all. Also, I talk fast, so if you want more of this, of course there's going to be a video, but speaker deck, I will put my presentation up there. Thank you guys.